Yes. Good morning students. Today onwards we are starting with the online classes. Please listen carefully and we are not going to repeat the same class again. Okay. I think for the B3 batch I have stopped with the hydrate formation of the hydrogen. Hydrate formation of the hydrogen. After that I have to explain the heavy water. Heavy water. Heavy water. Heavy water is nothing but the molecular formula of the heavy water is D2O. Molecular formula of the heavy water is D2O. This was synthesized, it's not the synthesized by, it is like just to separate the water, I mean from the water molecule, within the water molecule itself, this D2O molecule is present for about 29,000 liters of 29,000 liters of water, the normal water, when it is subjected to electrolysis process. When it is subjected to electrolysis process. First, initially, it was prepared by, in the year of 1966, by the scientist name is called as Urey. So he was separating the water, I mean the hydrogen and the oxygen from the water for about 29,000 liters. He subjected to the electrolysis process. So during the electrolysis process, the hydrogen, I mean the water which containing the hydrogen and the oxygen, hydrogen which get liberated on the surface of the cathode and the oxygen is liberated on the surface of the anode. So it is like a continuous process. So during the continuous process, hydrogen get liberated on the surface of cathode and oxygen get liberated on the surface of anode. So finally, at the end, for about 99% pure, 99% pure, 1 liter of water which is remaining, that 1 liter of water is nothing but a D2O. 1 liter of water which is remaining at the end, that 1 liter of water, it is nothing but a D2O. So the ratios are wide. 29,000 liters of water, normal water, which contains only 1 liter of D2O, that is nothing but a heavy water. So initially it was synthesized by, in the year of 1966, by the name, scientist name called as an Urey. Now let us study about the properties. Let us study about the properties of D2O, that is nothing but the heavy water. The physical properties are one and the same, that is for the water, we know that it is a colorless, odorless, tasteless liquid. The same like for the D2O also, it is a colorless, odorless, tasteless liquid. That is the physical property of the water. And now let us study about the chemical property of the water. Chemical property of the water. We know that, I mean the heavy water, we know that metals, general reactions, that is all the metals are reacting with the water, it gives rise to respective metal hydroxides and hydrogen gas is liberated. Here, metal when it is reacting with the D2O, metal is reacting with the D2O, it gives rise to, instead of the hydroxides, you need to write deuterated oxides, that is NaOD. So, I mean the deuterated sodium oxide plus hydrogen gas, instead of the hydrogen gas, you need to write deuterated gas. D2 gas get liberated. So it is like a reaction what you are writing for the water. Instead of the water, I mean the H2, you have to write the D2. Sodium, when it is treated with the D2O, it gives rise to sodium hydroxide, that is deuterated sodium oxide plus D2 gas get liberated. Another example, when magnesium is reacting with the D2O, it gives rise to NgOD twice deuterated oxide of magnesium plus D2 gas get liberated. That is all the metals reacting with the deuterated oxide and in the heavy water it forms respective hydroxides. Hydroxide ka badla you have to write it as deuterated oxides. That is the first reaction. When it is reacting with the metal oxide, that is like sodium oxide Na2O, sodium oxide. When it is reacting with the D2O, it forms respective hydroxide, that is NaOD plus D2 gas, D2. NaOD plus D2. Okay, so all the metal oxide. Let me give one more example. Sodium oxide. When it is reacting with the D2O, it forms deuterated CaOD twice plus D2. This is the second kind of chemical reactions for the deuterium. I mean the heavy water. Next, third reaction with the oxides of phosphorus pentoxide P2O5. When P2O5 is treated with the deuterated water, phosphorus pentoxide is treated with the deuterium oxide, that is nothing but the heavy water. It forms H3PO3, that is nothing but D3PO3, that is phosphoric acid is formed. When phosphorus pentoxide treated with the heavy water, it forms phosphoric acid. Phosphoric acid is nothing but the deuterated phosphoric acid. When it is treated with the NO2, nitrogen oxide, NO2, when it is treated with the D2O, it forms HNO3, that is DNO3. Instead of hydrogen, you need to write the D. Fourth reaction is exchange reaction. I mean the ion exchange reaction taking place. Ion exchange reaction, that is when sodium hydroxide NaOH, when it is treated with the deuterated water, that is the heavy water, hydrogen and the deuterium get exchanged. That is product formed is NaOD. Instead of hydrogen, you have to write the D. That is exchange of the ions will be taking place. Plus HDO. Instead of H2O, you have to write HDO. That is the exchange reaction between the hydrogen and the deuterium taking place. So these are the chemical reactions of heavy water. Next is types of water, that is hard water and the soft water. Hard water and the soft water. Soft water and hard water. We know that Purest form of the water is pure form of the water is it is a tasteless, odorless, colorless liquid. Soft water is considered as an the metal ions. It's like carbonates ion, Cl minus ion, Na plus ion, or the SO4 2 minus ion, which will be present in the calculated amount. Calculated amount in the sense how much quantity it is required, that much amount will be present with the soft water. Hard water is nothing but mainly the ions like HCO3 minus ion and CO3 2 minus carbonates ions, as well as Cl minus SO4 2 minus ion, and the metal ions like Mg2 plus ion, Ca2 plus ion. See, these ions are responsible for the hardness of water. Hard water which containing these many kinds of ions which is present in it. Soft water, mainly the differentiate between the soft water and the hard water we can do at home, that is using the soap. Okay, actually soft water, mainly the rainwater containing the soft water itself, but when it is coming in contact with the gaseous molecule which is present on the atmosphere, that is like sulfur dioxide, nitric oxide, carbon dioxide, when it is reacting with the water, I mean rainwater, when come in contact with the oxides of these elements like sulfur dioxide, carbon dioxide, as well nitric oxide, it reacting with the water, it gives rise to the acids like sulfuric acid, nitric acid, and this one carbonic acid is formed. That leads to the acid rain. Or if these gaseous molecules, I mean these kind of gaseous molecules, if it is not present, directly the rainwater touch on the surface of the earth. Earth surface may contain some of the minerals. I mean these ions, if it is present, like chloride ions, bicarbonate ions, sulfate ions, if these metal ions are present, that metal ions are soluble with the water. When it is soluble with the water, the property of the soft water changes, that property changes to the hard water. I mean the soft water changes into the hard water. Mainly the differentiate between the soft water and the hard water we can make with the soap. Almost colorless, odorless liquid, taste will be different. Hard water taste and the soft water taste will be different. That is with respect to the physical properties I am saying. With respect to the chemical properties, we can differentiate between the hard water and the soft water. So soap is nothing but sodium stearate, that is nothing but C17H35COONA. C17H35COONA is nothing but the soap. When soap is treated with the hard water, that is hard water containing the ions like M2 plus, I am writing M2 plus refers to Mg2 plus ion and the Ca2 plus ion which is present in the water. Mg2 plus ion or the Ca2 plus ion, I am representing the general equation, that is with respect to the M2 plus ion. So it give rise to sodium. See, this one is a sodium stearate. When it is mixed with the water, it forms the ions like the stearate ion, Na plus ion plus C17H35COO minus plus Na plus will be forming. COO minus plus Na plus ion will be forming. So when it is mixed with the water, it dissociate. It forms the respective ions like C17H35COO minus plus Na plus ion will be forming. So it gives rise to C17H35COO twice metal. because the metal carries the +2 charge and this one carries the -1 charge, so it is twice of this one. So whatever it is found, it is present in the precipitate state. Precipitate state is nothing but it is insoluble in water. It is insoluble in water. I mean it forms the precipitate, that's why it is insoluble in water. Okay. So using this we can make out how hard water is treated with the soap. I mean how hard water will be reacting with the soap. It forms the precipitate that is insoluble in water and it forms the NaS+. That's why hard water will not give lather to the soap. You can make out the precipitate. I mean white particles are formed. That white particles are nothing but the formation of metal spheroids are forming, so that is insoluble in water. So that is to identify the soft water and the hard water using the soap containing the sodium stearate. I hope all these points are clear now. Next, how can we purify the hard water into soft water? How can we purify the hard water into soft water? Next is we are studying about the hard water. See, the hard water itself, it has got two types of the hard water. One is temporary hardness. Temporary hardness of water. Second one is permanent hardness of water. Temporary hardness and the permanent hardness. Temporary hardness of water and the permanent hardness of water. See, the temporary hardness of water, we can remove the hardness by very simple methods. Permanent hardness requires some procedure. Okay. So first let us study about the temporary hardness of water. So the temporary hardness of water, it is mainly due to the bicarbonate ions which is present in the water, that is HCO3 minus, that is bicarbonate ion present with the Mg2 plus, Ca2 plus, Mg2 plus, Ca2 plus. Magnesium hydrogen carbonate or the calcium hydrogen carbonate, it is responsible for the temporary hardness of water. These ions are responsible for the temporary hardness of water. See, this temporary hardness of water, we can remove, we can separate the temporary hardness into the soft water. First method is by boiling process, and this boiling process is a very simple process. We can use at home also. If the hard water is present, we can soften the hard water. That is by boiling process. We need to boil the water. And we have to keep it for cooling. While keep it for the cooling, we can make out if you are boiling the water inside the vessel, after the cooling you can make out the two layers are formed. One is on the surface of the liquid, another one is below the surface of the liquid. I mean water vessel, water na ಮೇಲ್ಗಡೆ one layer will be forming, and at the bottom of the water is forming another layer. By filtration we can separate these two layers. That is the formation of magnesium hydroxide, magnesium carbonates are formed. So during the boiling process, the magnesium hydrogen carbonate MgCO3, HCO3 twice, magnesium hydrogen carbonate, during the boiling process, it forms magnesium carbonate MgCO3, magnesium carbonate, as well as magnesium carbonate plus H2O. Magnesium carbonate plus water is formed. We know that this magnesium carbonate is insoluble in water. Magnesium carbonate is insoluble in water. That's why it forms a precipitate. Another example, that is calcium hydrogen carbonate. When it is boiled during the boiling process, it forms calcium carbonate CaCO3, calcium carbonate plus H2O. We know that this calcium carbonate is insoluble in water, so it forms a precipitate. That's why during the boiling process we can make out the two layers on the liquid. One is at the bottom, another one is the top layer. One is make the formation of magnesium carbonate, calcium carbonate, as well as the magnesium hydroxide they also formed. So by boiling process we can separate these ions. Second method is by Clark's method. Clark's process or the Clark's method. In the Clark's method, it is, I mean, the hard water is treated with the lime water. Lime water is nothing but calcium hydroxide. When calcium hydroxide is treated with the hard water containing MgHCO3 twice or CaHCO3 twice, it gives rise to CaCO3, calcium carbonate plus magnesium hydroxide NaOH twice plus H2O. See, this calcium carbonate which is formed, it is in a precipitate state, as well as magnesium hydroxide is also in the precipitate state. So by filtration we can separate it. So when the hard water is treated with the lime water is nothing but the calcium hydroxide. So when calcium hydroxide is treated with the calcium carbonate, it forms calcium carbonate plus H2O. This calcium carbonate is insoluble in water. By filtration we can separate the calcium carbonate. So these are the two methods to remove the temporary hardness. And for the C section, I mean for the PCMC section, some corrections you need to do it. In the Clark's method, I said that it was treated with the calcium oxide. Please make a correction. It is treated with the calcium hydroxide. Okay. And I said that treating with the sodium carbonate was the Clark's method. No, it is not the Clark's method. Clark's method is nothing but to remove the temporary hardness. We need to add calcium hydroxide into the hard water containing the magnesium hydrogen carbonate, calcium hydrogen carbonate. Second method, I mean to remove the permanent hardness. hardness to remove the permanent hardness of water. To remove the permanent hardness of water, first method is treated with the sodium carbonate. Sodium carbonate is also called as an washing soda. It is also called as a washing soda. When washing soda is treated with that is Na2CO3, when washing soda is treated with the hard water containing, this permanent hardness is due to the chloride ion, sulfate ion which is present with the metal atoms, that is Mg2 plus Ca2 plus Cl minus ion, SO4 2 minus ion, Mg2 plus Ca2 plus ion. So these are the ions are responsible for the permanent hardness of water. So when sodium carbonate is treated with the water which containing Cl minus ion, SO4 2 minus ion and Mg2 plus ion, Ca2 plus ion, it forms, let me write the reactivity with the magnesium chloride. When sodium carbonate is treated with the hard water which containing the magnesium chloride, it forms NaCl plus MgCO3, NaCl plus MgCO3. See, this NaCl is soluble with the water, but if the quantity, if the percentage of NaCl is in excess, again we need to remove the excess quantity of the sodium chloride. This MgCO3 which is insoluble in water, it forms a kind of precipitate. By filtration we can separate the magnesium carbonate. Another example, that is with the calcium sulfate. It forms calcium carbonate CaCO3 plus Na2SO4 sodium sulfate, Na2SO4, and calcium carbonate is formed. This calcium carbonate is insoluble in water, it forms the precipitate, and sodium sulfate is soluble with the water. So by filtration we can separate it. That is to remove the permanent hardness using the washing soda, that is sodium carbonate. You can write the reaction with the calcium chloride as well as magnesium sulfate yourself. You can write the chemical reaction. The same kind of product will be forming. One is soluble, another one is insoluble. By filtration we can separate it. Second method is also called as an Calgen's process. In the Calgen's method, Calgen is the name of the chemical. Commercially it is called as a Calgen. Calgen is nothing but sodium Na6T6O18. Name of this one is sodium hexametaphosphate. Sodium hexametaphosphate. That is nothing but Na6T6O18. Sodium hexametaphosphate. It is nothing but Calgen. Commercially it is called as a Calgen's process. And the Calgen's process and the Clark's process is very important process. These questions will be asking for the NCERT for the 2 marks. How to purify the water by Clark's process, or how to purify the water by Calgen's process, and these methods are important for the competitive part also. So this Calgen's process, using this process, when Calgen is a chemical, that is Na6P6O18, when it is treated with the water, it forms the ion, that is Na2 Na plus ion is formed, 2 Na plus ion plus Na4 P6O18 2 minus. Na plus Na4 P6O18 2 minus. 2 minus charge is present, isn't it? This one we are treating with the hard water containing magnesium chloride or the magnesium sulfate or the calcium sulfate or the calcium chloride. When it is treated with the hard water, it forms Mg, that is NaCl, Na plus ion combining with the Cl2, it gives rise to NaCl plus Na4 Mg, because magnesium and the sodium carries the positive charge, that's why you need to write it together, and P6O18, which is insoluble and we can separate by the filtration process. So this process is called as a Carlson's process. And for this Carlson's process, you can write the general reaction. Let us write the general reaction now. That is Na6P6O18, when it is treated with the magnesium chloride, it gives rise to same reaction I am going to write Na4Mg plus NaCl. So this is how Carlson is reacting with the hard water. It contains the magnesium chloride. I hope you can write the reaction with the calcium chloride as well as the calcium sulfate, magnesium sulfate, isn't it? I hope you can write the chemical reaction with the calcium chloride, with the calcium sulfate, with the magnesium sulfate. Instead of magnesium, you have to write the calcium. Instead of this one, you need to write. These two products are one and the same. These two products are one and the same. And the byproducts are again it is NaCl, Na2SO4, Na2SO4 is formed, and it is soluble with the water. So that is by Carlson's process. Next is by ion exchange method. In this ion exchange method, mainly the resins are used inside the separating column. Resins are nothing but, it is like the show balls which we are using, like the size of the balls while you buying a pet shop, the very small, it's like a sachet size will be there. When it is put into the water, if you keep it for 3-4 hours, the size will be increases and the surface is very soft and the size is circular in shape and it is very soft surface. The same kind of, not that one, resins are nothing but it is like a soft surface will be there and transparent will be there. They are nothing but the resins, and these resins are nothing but sodium aluminium silicate. See, these sodium aluminium silicates are used as a resins. It is placed inside the column. See, the circular shapes is nothing but the resins which we have filled inside the column. It is like a burette in shape. It's like a short show balls. So they are nothing but the resins. That is mainly made up of sodium aluminium silicate NaAlSi4. And this sodium aluminium silicate, it is also called as an zeolites. They are also called as an zeolites. Zeolites I am representing as NaZ. Z refers to the aluminium silicate, sodium zeolite, NaZ. When it is treated with the hard water containing Ca2 plus ion, Mg2 plus ion, magnesium ion and the calcium ions which are present in the hard water. It is combining with the resins on the surface of the resins, exchange of the ions taking place, that is CaZ2, MgZ2, that is nothing but the sodium which is present on the resin get exchanged with the Ca2 plus ion. Just to get the exchanging, reactions will not be taking place inside the column. On the surface of the resins, Na plus ion and the Ca2 plus ion get exchanged. So Ca2 plus ion get accumulating on the surface of the ball. So it forms CaZ twice. Only on the ball surface I am saying, on the surface of the resins, it forming the CaZ2. So we are adding the water inside the column, so that water droplets comes, it is moving the downward direction. When it is moving downward direction, it is coming in contact with the resins. On the surface of the resins, exchange of the ions taking place. So at the end, water comes here. This one we are collecting inside the beaker. This one is nothing but the water, which containing mainly the Na plus ion in the water. Na plus ion, because calcium ion get exchanged with the resins, so the water containing the Na plus ions, it may present in the Cl minus ions also. So resins exchange the Ca2 plus ion with the Na plus ion. So Na plus ion goes to the water and Ca2 plus ion goes to the resins, that is CaZ2 or MgZ2 is formed. So Na plus ion with the water, see this one is the water which containing the Na plus ion. So we can separate the Mg2 plus ion and Ca2 plus ion with the ion exchange process. So this is this is the one more method of purification of the water. Mainly the metal ions get exchanged in the ion exchange process. So these are the three processes to purify the permanent hardness of water. Next is, I hope it's understood. Next one is hydrogen economy. Hydrogen economy means, see, before this one hydrogen economy, I need to explain the hydrogen peroxide, H2O2. H2O2 is nothing but the hydrogen peroxide. This preparation of the hydrogen peroxide, chemical properties of the hydrogen peroxide and the structure of the hydrogen peroxide is not there for this year. For the NCERT, it's been deleted, but you should know what is the hydrogen peroxide, H2O2. But for the competitive part it's there H2O2, but for the theory part, NCERT part, H2O2, hydrogen molecule, the hydrogen peroxide molecule preparation, chemical properties, uses and the structure of the hydrogen peroxide has been deleted. That's why I am not going to explain the hydrogen peroxide. Next one is the hydrogen economy. Hydrogen economy is nothing but what are the uses of hydrogen in our day-to-day life. We know that hydrogen is a highly combustible substance. It is an highly combustible substance. Highly combustible substance is nothing but hydrogen catches the fire or hydrogen undergo combustion process very easily. When hydrogen combining with the oxygen, it forms H2O. It forms the main product as a H2O. That's why instead of the fossil fuels, we can use the hydrogen as a fuel. But still we are not using the hydrogen as a fuel in our day-to-day life. We are using the fuels that are nothing but the fossil fuels. Fossil fuels are nothing but the petrol, diesel or the kerosene or the LPG we are using in our day-to-day life. That is to run the industries or that is to run the automobiles or any kind of the industries. These requires the fuels. It may be in terms of petrol, diesel, kerosene or the LPG. When these fossil fuels, when it is burned is nothing but when it is combining with the oxygen, it liberates many kinds of oxides like carbon dioxide gas, sulfur dioxide gas, nitric oxide gas. So these kinds of oxides are generating or the liberating during the combustion of these fossil fuels, maybe the liquid petroleum gas or the petrol or the diesel or the kerosene. When during the combustion process it liberates these kinds of oxides, and we know that these oxides are polluting agents. They are not good for the health. They cause the environmental pollution, and during the combustion process it consumes and it uses the oxygen gas. We know that nowadays scarcity of the oxygen is mainly due to this reason also, because for the combustion of the fossil fuels it requires the oxygen. So scarcity of the oxygen taking place, as well as we are getting the environmental pollution as well. We know that these fossil fuels are non-renewable resources. It requires more than millions of years to form. The fossil fuels, and they are the non-renewable materials. Still in our day-to-day life we are using the fossil fuels. We are not applying the hydrogen as a fuel. Instead of the fossil fuels, we can use the hydrogen as a fuel. And instead of the nuclear reactor, I hope you have learned about or you have heard about the nuclear reactors. Mainly in the nuclear reactors, energy is liberated, heat energy is liberated during the nuclear reactors process. That heat energy is converted into electric energy. For the running of the industries we require the electricity, so electric energy is required. Even in our day-to-day life we are using the electricity, so heat energy is converted into electric energy. Conversion is okay, but during the nuclear reactor process it forms the byproduct. That byproducts cause the environmental pollution. So we are dumping converting these nuclear reactors byproduct into the sea or under the earth, because it leads to the decay. During the decay process, it liberates the rays. That rays are not good for our health. So nuclear reactors is not I mean the nuclear reactors also leads to the environmental pollution. That's why we can replace the fossil fuels with the nuclear reactors. Fossil fuels with the nuclear reactors into the hydrogen as the fuel. We know that for about 71% of the earth is covered by water. It may be in soft water, it may be in hard water, whatever it may be. The earth is covered by 71% of water. So we can separate the hydrogen gas, we can separate the hydrogen gas from the water by the electrolysis process. So by the electrolysis process, we can separate the hydrogen from the water, H2O2 as a H2 and O2. Hydrogen is liberated at the cathode, oxygen is liberated at the anode. Now afterwards we can compress the hydrogen, and hydrogen is converted into the liquid state. That liquid hydrogen is used as a fuel in the vehicles, in the automobiles, or it may be in the industries also, because during the combustion of hydrogen, main product is the water, and it liberates the more quantity of the energy also. That energy we can utilize in the automobiles as well as in the industries. But the thing is, main drawback, one of the uses of the hydrogen, that is from the 2001 onwards, we are using the CNG. CNG is nothing but a compressed natural gas. This compressed natural gas is mixed with the 5% of liquid hydrogen. This 5% liquid hydrogen, which one is used in the automobiles? Mainly in the auto rickshaws it is used in the automobiles. So it leads to the less environmental pollution. It reduces the environmental pollution. But we are using the 5% of hydrogen, not more than that. Isn't it? We are using only 5% with the compressed natural gas. We are not using the 100% of hydrogen. Why we are not using the 100% of hydrogen? Main drawback of this hydrogen is it is highly combustible substance. So the transportation from one place to another place, it requires more energy, and it is highly dangerous one. And during the transportation, temperature will be varied. During the temperature variation, there is a chance of explosion, because hydrogen which is present in the liquid state only at a lower temperature. When we raise the temperature, it changes to the gaseous state, so it gets expanded. Explosion will be taking place. That's why we are not using the hydrogen in the automobiles or in any industries. Main cause is it leads to the explosion and transportation, and transportation and storing and the transportation is very difficult. That's why hydrogen we are not using as the fuel in our day-to-day life. Only 5% of the hydrogen is used with the compressed natural gas, that is mainly in the automobiles industries it will be used. So this is the end of the hydrogen topic. Thank you.